All right. Wait till he comes back and then you can go. All right, tell me, what is a polynomial? Polynomial. 4 and more. Okay, so it could have 4, but it could have more than 4, right? It means many terms. And when I talk about terms, I'm talking about the little pieces in the equation or the expression. What is a monomial? If polynomial is many terms, what's a monomial? One term. You're exactly right. All right, so here's what we're going to do. I want you to look at the very first example. Is this a polynomial divided by a monomial? Yes, okay. Monomial, and put yourself a note, means no addition or subtraction. You write that down, Trevor? Write it with me. Write it with me. Don't kick him, Dustin. Look, monomial. Circle it. Highlight it. Something, Max. Do something to it so it draws your attention to it. When these are gone, they're gone. You're very welcome. All right. Monomial means no pluses or minuses in there, okay? So this only happens when it's in the bottom of the fraction. Y'all stick with me, okay? I got to get you through enough of this to get you through 2 days when I'm not going to be here, okay? So it's going to be a little bit boring, and I apologize. Bro, I got like one more. That's all I got. Let me find the page. Oh. You certainly may. You're welcome. Here. All right. I'm dividing a polynomial. All right, my back table. My back table. Here's what I'm going to do. I'm going to split it up into separate fractions, okay? And this only works whenever I got a monomial on the bottom. And to do that, I always circle them because it helps me. I'm going to make a fraction out of this, okay? So 8n squared over 4n. Then, watch, pay attention. I'm going to make a fraction out of this one. If I had, guys, I am not going to fight y'all to teach you this now. Stay with me. Minus, because that's the sign here, 36n over 4n. Okay? And now what I'm going to do is simplify each one on their own. So here's where I'm going to use my calculator, okay? What is 8 divided by 4? 2. Everybody okay with that? So the numbers in front, I'm going to divide. And what do I do with the exponents whenever I'm dividing this way? Subtract them, okay? Here's how I remember. To me, this division sign looks like a big subtraction sign, and that helps me remember that I'm going to subtract top minus bottom, okay? If you don't remember it, you can think about it like this. N to the second means 2 n's written out beside each other. One on the bottom, and so you can cancel out what's the same. Whichever way helps you. All right, so if I subtract, what's 2 minus 1? 1, so I've got n, and I could write the 1 or I could leave it off. It doesn't matter. Right? Now go to the next fraction. What happens when you divide 36 by 4? 8. So I've got that minus in the middle, 8. And what happens to these ends? What's 1 minus 1? 0. It goes away. Oh, sorry. Thank you. Sorry, okay. So, if you like the subtracting, you can subtract. If you like to write them out, you certainly may write them out. Let me show you what I mean here. This is just a little side note. If I had x to the 5th over x to the 2nd, what should that give me? X to the 3rd. That's exactly right. And how did you get x to the 3rd, Maddie? Subtracted the 5 and the 2, right? That's how I got that. Now, if you don't understand the subtracting so much, when you raise it to an exponent, that tells you how many times to multiply it. So this would say multiply that x 5 times. And on the bottom, I've got 2 of them, right? And now start canceling out. How many's left? 3. Isn't that what 5 minus 2 is? So it's the same thing, okay? Let's look at the second example together. Y'all ready? Here we go. Negative 14x to the 12th, y to the 5th, plus 7x squared, y squared. Trevor, tell me what's on the bottom. Read it to me. That's exactly right. What should I do now? Is monomial. Is what's in the bottom of monomial. What's monomial mean? One term, nothing's what? You don't know skibbity toilets. You don't see any what or what? Pluses or minuses in there. Do you see any? No. Is it a monomial? Yes. Because there's no plus or minus. It can have different variables. It just can't have the plus or minuses in between. Yep. Yep. All right. So I'm going to split this up, boys, the same way. Poor Nevaeh. She's over there with these boys. It's just goofing off. I know. So I'm going to split up. What happens when I divide the numbers in front? What's negative 14 divided by 7? Negative 2. Actually, let me go ahead and write it, and then we'll simplify it. So I show all my steps. There's the first fraction. Max, what's going to be on top of my second fraction? The yellow?
Oh, we're doing the yellow one?
Well, I just wrote the green one, but now we're doing, tell me the second fraction, what I circled in. 7x squared y squared over, what's in the bottom? See how we're taking that same bottom and it's going to both pieces up top? We're making separate fractions out of it. Does everybody see what we're doing? Splitting it up. That's all we're doing, splitting it up. And then we're going to look at each one by itself to figure out what it's doing, okay? All right, I hope you're writing this on your paper as well. First fraction, you already told me if I divide negative 14 by 7, I get what? Negative 2. Now look, I've got all these variables and I've got all these exponents. What should I do? Subtract what where? The 2 x's, I've got 12 up top and 2 in the bottom. How many does that leave where? 10 up top, right? So x, 10. y3. That's exactly right, because I'm subtracting those. If it's hard for you to see that, write them out that many times. Okay? Now, look at the second one. Look at that second one. What do you notice? So it would leave what? Anything divided by itself. 1. 1. Anything divided by itself is always 1. If you have 5 over 5, that's 1. If you have 2 over 2, that's, oh, excuse me, anything over itself is 1. All right, Max, you with me over there? What you doing? So what you doing on that computer?
I'm doing your book.
Why are you doing the booklet from Friday? You wouldn't be bored if you write this down. Lord, that's a lot of cookies. All right, let's go on down. Look at number 1 with me. Everybody look at number 1. To me. Read me number 1. No, not whenever everything cancels. If everything cancels, it's just 1. All right. All right. Am I dividing by a monomial? Yes. How do you know? In the bottom, there's no plus or minus. Does everybody see that? All right. Split it up. What do my fractions look like when I split this up? The first one, what is it? But give it to me as a fraction. You're right. 6x over 3. What's my next fraction look like? Is anybody confused on how we're splitting these up? All right, now let's clean them up. 6x divided by 3, what do you get? 2 what? 2x, that's exactly right. How about 9 divided by 3? Look at number 3. Eight a to the third minus, Am I dividing by a monomial? Yes, I am. How do I know, Matt? There's no plus or minus. Tell me what my first fraction is, Matt.
8a. Oh.
Go ahead.
3 over a, and then I don't know.
And then what? Then I go to the next term, right? Keep the sign with it. What's the sign that's with it? Subtraction. Minus 2a squared over what? A. What's my third fraction look like? Plus or minus? Plus 5a over a. Boys, for me. Look at the green fraction first. What should I do? Minus the exponents. You're exactly right. I don't see an exponent on the bottom, though. So you just put a 1. What's 3 minus 1? 2. So 8a2 minus, what happens in that next one? Same thing. So I got 2a. What's the exponent? 1. Do I have to write 1? No, it's implied. How about that very last one? The A's cancel each other out, and I'm just left with 5. Try number 5 on your paper by yourself. Number 5 by yourself on your paper. That's the A. Yep. Oh, sorry. Max. Did it. This is number 5. All right. To me, am I dividing by a monomial? Why? Put your feet on the floor. There's no plus or minus in the bottom. That's exactly right. All right. You can't do it because you ain't paying attention. Now, when I split the fractions up, give me the first fraction. That's exactly right. There's my first one. What's my second fraction? What's my last one? All right, let's work with the numbers in front first, and then let's move on to the variables. How about the first one? 6C, and then 3 minus 1, 2. That's exactly right. Minus 21 divided by 3. Look at y'all. How about 3C over 3C? Flip over. Let's look at 15 together. Last one together, and then I got some work for you to do. This looks worse than it is. Yep, flip it over. Max, stay with me, buddy. This is light work. Who said this is light work? We like your smart path. All right. While you're writing that, it's number 15. It's already written down for you. Now, am I dividing by a monomial? Yes. Why? There's no plus or minus, even though there are multiple variables in here. There is no plus or minus in the bottom. So let's split it up into our separate fractions. First fraction, 28, x to the 5th, y to the 4th, z to the 3rd, write this down, over 4x squared, y squared, z squared. That's my first one. Did you write it down, Max? Write it down, write it down. My second fraction. Bro, you wasn't even on the right page. How'd you write it down? Second fraction. 8x4y3. Yep. Over. Nope. Samik, sit down. Yep. All right. Let's work with the numbers in front first, and then we'll worry about the exponents. Look at the yellow one. Tell me what I end up with. What's 28 divided by 4? Where'd you get 3 on the x? What'd you do? Subtracted the 2, right, Trevor? Y'all quit playing footsie. 4 minus 2 is what? 2. And then 3 minus 2 is a 1. So I put a line through the Z so you can tell a difference. Okay? Look at the pink one. Trevor's going to take this one for us. 8 divided by 2 is what? Oh, 8 divided by 4. I'm sorry. It's 2. Now look at the x's. Subtract the exponents on them. What do you get? 2. How about the y's? How about the z's? See, you're just listening. Just the whole thing is 1, not the exponent. So it cancels out. I don't have to put it. Okay, if it cancels out, don't put it. And now you're done. All right, let me tell you what I got for you.